Hello students, welcome to your channel Parivartan Physics. See, we are in the series of videos where we are going through a course called as Rapid Revision course for KCET 2025. Right? So in these videos, we are revising one chapter in one video with all the formula, shortcuts, concepts and concepts of that every chapter we are seeing in these videos. Right? So we'll quickly see all the concepts related to magnetism and matter in this video. So previous chapters have already been covered, videos are already uploaded. You can just go through the playlist, you will find the videos on other chapters also. Right? Okay. And without making any delay, let us start with the video then. See, here magnetism and matter, it is a theory chapter you should be knowing very clearly. So concepts are very much required, especially magnetic materials are very important. So you have to remember all the properties of that magnetic materials. Okay, let us go from the basic, that is magnetic dipole moment. See, whenever you are considering a magnet, it is a bar magnet. Magnet ante enadru tondre illa namak bar magnet ante irtade. Bar magnet always has two poles, north pole and south pole. So it is called as dipole. Right? So dipole andamele adukku dipole moment irbeku. Dipole moment is nothing but pole strength into the length. Pole strength into the dipole length, right? So dipole moment is product of pole strength into the dipole length. See, if this is a bar magnet, then the distance between, here I have written, if this is a bar magnet, the distance between north pole and south pole is called the dipole length, and magnetic moment is always directed from south to north. Pole strength is something related to the pole. It is the attracting capacity of that pole, right? So how do you write the electric dipole moment? In the same way we will be writing this magnetic dipole moment. Electric dipole moment is 2a, length of the dipole into the charge. In the same way, length of the magnetic dipole into the pole strength. Like this we'll be writing, right? So this is the magnetic dipole moment of a bar magnet. SI unit of magnetic dipole moment is ampere meter square. 2L is the dipole length, M is the magnetic pole strength. Okay. Next, we'll see some concepts which are not in theory but required for CET. That is cutting off magnet. Right here, in cutting off magnet, pole strength will also change and dipole length will also change. But it depends on how are you cutting that magnet. On that it depends. See, first thing is, if we cut a magnet in n equal parts parallel to its axis. Right. So this is the axis of the dipole. This is the axis of the dipole. If you cut parallel to the axis of the dipole, then what happens here is, if you cut them in n equal parts, then here pole strength will get reduced by n times. How many parts you cut it, in those many times it will get reduced. If you cut it in 10 pieces, it will get reduced by 10 times. If you cut it in 20 pieces, it will get reduced by 20 times. Like that it is, right? So by cutting the magnet parallelly, pole strength will get reduced, but magnetic length will remain same. 2L will remain same. So while writing the new magnetic dipole moment, pole strength will be m by n into the magnetic length is 2L. That's why the new magnetic dipole moment will be m by n. Before cutting, how much was the magnetic dipole moment? It was m. After cutting in n equal parts parallel to axis, it will become m by n. Okay, here we cut the magnet parallel to the axis of the dipole. Next, if we cut the magnet in n equal parts perpendicular to the axis of the dipole. Instead of cutting like this, we'll cut it like this now. Like this we will cut it. Right, in n pieces. So when you cut a magnet perpendicular to its axis, its pole strength remains the same, but magnetic length decreases by n times. 2L is 2L by n ಆಗ್ತದ್ರಿ, right? So new magnetic dipole moment will be pole strength into 2L by n. That is nothing but m by n. So here also the magnetic dipole moment got reduced by n times. Here also the magnetic moment got reduced by n times. But the difference is, here pole strength gets reduced, dipole length remains the same. Here pole strength remains the same, dipole length gets reduced. Right? Okay, next, if we cut in x parts parallelly and y parts perpendicularly, we are cutting parallelly also and we are cutting perpendicularly also, then both the quantities will get reduced. Pole strength will reduce by x time. Yes, pieces horizontally you cut divide madಬೇಕು. If you cut it in 3 pieces horizontally, then it will be m by 3. If you cut in 5 pieces vertically, then it will be 2L by 5. Right, like that it will be. So the new magnetic dipole moment will be m dash equal to m divided by x into y. Number of pieces parallel to the axis, number of pieces perpendicular to the axis, x into y. Right? Okay, let us go to the next concept then. See, bending of magnet. In bending of magnet, m remains the same, dipole length goes on changing. So here first we have bent a magnet in U shape. right? ಒಂದು ಮ್ಯಾಗ್ನೆಟ್ ಅದ m ಡೈಪೋಲ್ ಮೂಮೆಂಟ್ ಇರುವಂತ ಮ್ಯಾಗ್ನೆಟ್ ಅನ್ನ ಅದನ್ನ ನಾವು 3 ಈಕ್ವಲ್ ಪಾರ್ಟ್ಸ್ ಒಳಗೆ ಬೆಂಡ್ ಮಾಡಿದೀವಿ. 3 ಈಕ್ವಲ್ ಪಾರ್ಟ್ಸ್ ಒಳಗೆ in the shape of U we have bent it. All these 3 parts are having same length. All these 3 parts are having same length, right? See, this is north, south pole, this is north. If this is north, this has to be south. If this is south, this will be north. If this is north, this has to be south. And if this is south, this will be north. Magnetic dipole moment is always directed from south to north. So, ಇಲ್ಲಿ 3 equal pieces ಒಳಗೆ ನಾವು ಬೆಂಡ್ ಮಾಡಿರೋದ್ರಿಂದ m magnitude ಇದ್ದು 3 equal pieces ದಾಗ ಡಿವೈಡ್ ಆಗ್ತದೆ. m by 3, m by 3, m by 3. Right? So, this will be m by 3, dipole moment of this m by 3, dipole moment of this m by 3, dipole moment of this m by 3. So, here what happens? The two dipole moments will get cancelled. This m by 3 and this m by 3 will get cancelled. So finally the remaining magnetic dipole moment is m by 3. So the net dipole moment of this U-shaped magnet is m by 3. In the same way, if we bend it in the S shape, see, if this is south, this will be north, and if this is north, this will be south, south, north, north, south, south, north, north, south, south, north, north, south, north. So dipole moments are in this direction. See, in how many pieces it has been bent? 5 pieces, 5 equal pieces. 1, 2, 3, 4, 5. So dipole moment will get divided in 5 equal pieces, 5 equal parts. M iddudu m by 5, m by 5, m by 5, m by 5, m by 5. It will get divided. So here it is m by 5 left side direction, m by 5, m by 5, m by 5, m by 5. Correct? So here what happens? This dipole moment and this dipole moment are equal and opposite in direction. They will get cancelled. Now what is the rest of the thing? This dipole moment is remaining, that is m by 5. This is m by 5. This dipole moment and this dipole moment are in same direction, m by 5, m by 5. So it will be 2m by 5. 2m by 5, right? So these many dipole moments are now remaining. Since these both are perpendicular to each other, you apply root of p square plus q square, root of m by 5 square plus 2m by 5 square, you will get the resultant this much. M dash is equal to m by root 5. This much will be the resultant magnetic dipole moment of this S-shaped magnet. Okay, next, if we bend a magnet in such a way that it is bent at the midpoint, the magnet is bent at the midpoint such that the two sides or the two halves of the magnet will be subtending an angle theta in between them, right? So in such case, how much will be the magnetic dipole moment? To calculate that, we have the formula m dash equal to m sin theta by 2. M dash equal to m sin theta by 2, right? Okay, if the angle is given, for example 60 degree, it will become m by 2, 90 degree m by root 2, 120 degree root 3 m by 2, right? So if it is bent at a certain angle, then by using this formula you will get the dipole moment. Next, if a magnet is bent in the form of an arc, that was the magnet bent at the midpoint in such a way that the two halves will be subtending a certain angle, correct? Here the magnet is bent in the form of an arc. Okay, so if it is bent in the form of an arc, a dipole moment of that will be 2m sin theta by 2 by theta. 2m sin theta by 2 by theta. Okay, for semicircle ka angle ಎಷ್ಟು ಇರ್ತೈತ್ರಿ? pi, 180 degree. So if I substitute pi here, it will be 2m by pi. 2m by pi, this will become sin 90, sin 90 is 1. So 2m divided by theta, theta is pi, 2m by pi is the magnetic dipole moment of bar magnet which is bent in the form of a semicircle. Okay. Let us go to the next concept now. See, properties of magnetic field lines you should be knowing. Magnetic field lines theory again properties of the properties in n category. We know very well magnetic field lines will start from north pole and they will enter inside the south pole in the air. Outside the magnet in the air, the field lines will be passing from north to south. Inside the magnet, they will be passing from south to north. So since they are passing from north to south in the air and inside the magnet from south to north, it is forming a closed loop. Electric field lines will not form the closed loop. Magnetic field lines will form the closed loop. Correct? And after that, magnetic field lines will never intersect each other. At any point, if you want the direction of the magnetic field, draw the tangent to that magnetic field line. You will get the direction of the magnetic field at that point, right? And magnetic field lines will never intersect each other. If they intersect each other at a single point, you will get two different directions and two different magnetic fields at that point, right? Okay, well, so in next magnetic field lines the properties ನಿಮಗೆ ಏನು ಥಿಯರಿ ಒಳಗದಾವ ಅದನ್ನ ಓದ್ಕೊಳ್ರಿ. ಈಗ ನೆಕ್ಸ್ಟ್ ನೋಡ್ರಿ, ಎಲೆಕ್ಟ್ರೋಸ್ಟಾಟಿಕ್ಸ್ ಮತ್ತು ಮ್ಯಾಗ್ನೆಟಿಸಮ್ ಎರಡೂ ಕಂಪೇರ್ ಮಾಡಿ ನಾವಿಲ್ಲಿ ಕೆಲವೊಂದಿಷ್ಟು ಫಾರ್ಮುಲಾಸ್ ಬರೀಬೇಕು. Electrostatics ಒಳಗ we take an electric dipole. Electric dipole means two equal and opposite charges separated by a distance called as 2a, small distance, and the dipole moment will be from negative charge to positive charge. In magnetism, magnetic dipole means it is a bar magnet. North pole and south pole. These poles are having the strengths, equal strength M and M, and the magnetic length is 2L, the length between the south pole and north pole, right? That is the magnetic dipole length. And dipole moment of the magnet is always from south pole to north pole. Dipole moment, capital M, right? Okay, so ಈಗ electrostatics ಮತ್ತು magnetism ಎರಡನ್ನೂ ಕಂಪೇರ್ ಮಾಡಿ ನಾವು ಈಗ ಫಾರ್ಮುಲಾಸ್ ಬರಿಬೇಕು. We'll write comparing the formulas from electrostatics to the formulas in magnetism. What all replacements we have to do here? See, you have to replace charge by pole strength, dipole moment, electric dipole moment by magnetic dipole moment, electric field by magnetic field, epsilon naught by mu naught, relative permittivity by relative permeability, 1 by 4 pi epsilon naught by mu naught upon 4 pi. ಅಂದ್ರೆ ನಿಮ್ಗೆ ಯಾವ ಫಾರ್ಮುಲಾದಾಗ 1 by 4 pi epsilon naught ಬರ್ತಿತ್ತ ಅಲ್ಲೆಲ್ಲ ನೀವು ಏನಂತ ಬರೀಬೇಕು, mu naught upon 4 pi ಅಂತ ಬರೀಬೇಕು. Okay, next, see, by Coulomb's law we know very well, F is equal to 1 by 4 pi epsilon naught Q1 into Q2 by R square is the force between the two charges. F is equal to Q into E is the force acting on a charge in the electric field. Similarly, what we have to do, we have to replace this 1 by 4 pi epsilon naught by mu naught upon 4 pi. Charges by pole strength, M1 into M2 divided by distance square, right? So here it is charge into electric field, here it will be pole strength into the magnetic field. So we are just replacing the things like this, right? Next, electric field due to a point charge, 1 by 4 pi epsilon naught Q divided by R square, and that will magnetic field due to a pole strength, magnetic field due to a single pole, monopole. Actually monopoles are not existing in the nature. Monopoles illa, ಇರೋ ಏನ್ ಮ್ಯಾಗ್ನೆಟ್ಸ್ ಅದಾವ ಎಲ್ಲಾನು ಡೈಪೋಲ್ಸ್ ಅದಾವ್ರಿ. ಬಟ್ ಥಿಯರಾಟಿಕಲಿ ನಮ್ಗೆ ಏನಾದ್ರು ಒಂದು ಮೊನೋಪೋಲ್ ಅದ ಇಮ್ಯಾಜಿನ್ ಮಾಡ್ಕೊಂಡು ಫೀಲ್ಡ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ರಿ ಅಂತ ಕೇಳಿದ್ರೆ ಯು ಹ್ಯಾವ್ ಟು ಯೂಸ್ ದಿಸ್ ಫಾರ್ಮುಲಾ ಟು ಕ್ಯಾಲ್ಕುಲೇಟ್ ದ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್, ರೈಟ್? ಇಟ್ ಇಸ್ mu naught upon 4 pi M by R square. See, here the constant is 1 by 4 pi epsilon naught. In that place we have to write mu naught upon 4 pi. Charge, pole strength, distance square, right? Next, electric dipole moment, dipole length into the charge, electric dipole length into the charge, magnetic dipole moment, capital M, dipole length 2L into the pole strength, M, right? Next, axial electric field, 1 by 4 pi epsilon 2p upon R cube. Axial electric field at an axial point, 1 by 4 pi epsilon 2p upon R cube. Axial magnetic field at the axis of the magnet. See, formula 1 by 4 pi epsilon naught mu naught upon 4 pi, 2 into electric dipole moment, 2 into magnetic dipole moment, divided by R cube, right? Equatorial electric field, 1 by 4 pi epsilon naught P by R cube, magnetic field mu naught upon 4 pi M by R cube, right? So we are just going on replacing. So by replacing you will get the formulas. Ignore really kuda. Electric field at any general point, 1 by 4 pi epsilon naught P by R cube root of 3 cos square theta plus 7. Magnetic field at general point, mu naught upon 4 pi M by R cube root of 3 cos square theta plus 1. Everything is same, we are just replacing the things. P E sin theta torque, M B sin theta. Work done. P E cos theta minus cos theta 1, M B cos theta 1 minus cos theta 2. Potential energy, minus P E cos theta minus M B cos theta. Time period, 2 pi root of I by dipole, electric dipole moment into electric field. 2 pi root of I divided by M into B, magnetic dipole moment into magnetic field. I is moment of inertia. Electric potential of a dipole, 1 by 4 pi epsilon P cos theta upon R square. Magnetic potential due to a magnetic dipole is mu naught upon 4 pi M cos theta divided by R square. Right? Hope you have understood these things. We'll go to the next concept. See, before going to magnetic materials, we should be knowing these terms. You theory just you have to remember the formulas. I'm just going to remind you these things. Magnetic intensity of magnetizing field ಅಥವಾ magnetic intensity ಅಂತ ನಾವು ಏನು ಕರಿತೀವಿ, it is formula of that is B divided by mu naught or N into I. SI unit is ampere meter. What is this magnetic intensity? See, if this is a magnetic field in which I am keeping a magnetic material which is going to get magnetized, ಅಂದ್ರೆ ಇಲ್ಲಿ ನಾವು ಒಂದು magnetic material ಇಟ್ಕೊಂಡಿದ್ದೀನಿ, ಅದು magnetized ಇಲ್ಲ, it is not magnetized. Magnetized illa andre adರದ meaning ಏನ್ರಿ? See, if it is here, ಇಲ್ಲಿ ನಮಗೆ ಅದು ಪೀಸ್ ಅದರಿ, near to this I am keeping a iron piece, ಒಂದು iron piece ನ ಇಟ್ಟಾತೀನಿ, it is not attracting that iron piece, right? This magnetic material is not attracting that iron piece. Why? Because this is not magnetized. ಇದು ಇನ್ನೂ magnetize ಆಗಿಲ್ಲ. Magnetize ಆಗಿಲ್ಲ ಅಂದ್ರೆ ಅದರ ಅರ್ಥ ಅದರ ಒಳಗಡೆ magnetic dipole moment zero ಅದರಿ. It has zero magnetic dipole moment. That's why it is not attracting. Right? So we have to magnetize that. It should get magnetic properties to attract that material. That's why we have to magnetize this. So ಈ material magnetize ಮಾಡ್ಲಿಕ್ಕೆ, to magnetize this material I am keeping it in a magnetic field. ಒಂದು field ಒಳಗೆ, magnetic field ಒಳಗೆ ನಾನು ಅದನ್ನ ಇಟ್ಕೊಳ್ಳಕತ್ತೀನಿ. Right? I am keeping it in an external magnetic field. When you keep it in an external magnetic field, at that time, magnetic dipole moments will get developed inside that. ಅವಾಗ ಅದ್ರೊಳಗೆ magnetic dipole moments develop ಆಗ್ತಾರೆ. And you bring it outside now, you bring it outside, and if it is a ferromagnetic material, now it will start attracting, now it will start attacking the materials. Then what does it mean? It means that it has got magnetized. ಇಲ್ಲಿ ಇನ್ನೂ ಮ್ಯಾಗ್ನೆಟೈಸ್ ಆಗಿರ್ಲಿಲ್ಲ, ಇಲ್ಲಿ ನಾವು ಫೀಲ್ಡ್ ಒಳಗೆ ಇಟ್ಕೊಂಡಿದ್ದ ಕೂಡಲೇ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಮೂಮೆಂಟ್ಸ್ ಅದ್ರೊಳಗೆ ಡೆವಲಪ್ ಅದು ಮ್ಯಾಗ್ನೆಟೈಸ್ ಆಯ್ತು. ಇಟ್ ಹ್ಯಾಸ್ ಗಾಟ್ ಮ್ಯಾಗ್ನೆಟೈಸ್ಡ್, ರೈಟ್? ಇನ್ ನೋಡ್ರಿ, ಫೀಲ್ಡ್ ಒಳಗೆ ಇದ್ದಾಗಂತೂ ಅದಕ್ಕೆ ಮ್ಯಾಗ್ನೆಟಿಸಮ್ ಇರತ್ತದ್ರಿ. ಡಿಪೆಂಡಿಂಗ್ ಆನ್ ದ ಟೈಪ್ ಆಫ್ ಮಟೀರಿಯಲ್, ಇಟ್ಸ್ ಮ್ಯಾಗ್ನೆಟಿಸಮ್ ವಿಲ್ ರಿಟೈನ್ ಆರ್ ಇಟ್ ವಿಲ್ ವ್ಯಾನಿಶ್. ಇಟ್ ಡಿಪೆಂಡ್ಸ್ ಅಪಾನ್ ದ ಮಟೀರಿಯಲ್. ಆ ಫೀಲ್ಡ್ ದಾಗಿಂದ ಹೊರಗೆ ತೆಗೆದು ಕೂಡಲೇ ಕೆಲವೊಂದು ಮಟೀರಿಯಲ್, ಸ್ಪೆಷಲಿ ಫೆರೋಮ್ಯಾಗ್ನೆಟಿಕ್ ನಾವು ಫೀಲ್ಡ್ ದಾಗಿಂದ ಹೊರಗೆ ತೆಗೆದು ಕೂಡಲೇ ಅದಕ್ಕೆ ಮ್ಯಾಗ್ನೆಟಿಸಮ್ ಇರ್ತದ್ರಿ. ಬೇರೆ ಮಟೀರಿಯಲ್ಗೆ ಮ್ಯಾಗ್ನೆಟಿಸಮ್ ಭಾಳ ಇರಂಗಿಲ್ಲ, ಇಟ್ ವಿಲ್ ಗೆಟ್ ವ್ಯಾನಿಶ್ಡ್, ರೈಟ್? ಒಟ್ಟರಾಗೇನೋ ಮ್ಯಾಗ್ನೆಟೈಸ್ ಅಂತೂ ಆಗ್ತದೆ. ಸೊ ಇಲ್ಲೇ ನಾವು ಮ್ಯಾಗ್ನೆಟಿಕ್ ಇಂಟೆನ್ಸಿಟಿ ಅಂತ ಅನ್ನತ್ತೀವಿ. ಮ್ಯಾಗ್ನೆಟಿಕ್ ಇಂಟೆನ್ಸಿಟಿ, ದಟ್ ಈಸ್ ದ ಕ್ವಾಂಟಿಟಿ ರಿಲೇಟೆಡ್ ಟು ದಿಸ್ ಫೀಲ್ಡ್ ವಿಚ್ ವಿ ಆರ್ ಯೂಸ್ ಟು ಮ್ಯಾಗ್ನೆಟೈಸ್. ನಾವು ಮ್ಯಾಗ್ನೆಟೈಸ್ ಮಾಡ್ಲಿಕ್ಕೆ ಯೂಸ್ ಮಾಡಿದಂತ ಫೀಲ್ಡ್ ಮೇಲೆ ಡಿಪೆಂಡ್ ಅದು. ಈಗ ನೋಡ್ರಿ, ಫಾರ್ ಎಕ್ಸಾಂಪಲ್, ಈಗ ನಾವು ಈ ಫೀಲ್ಡ್ ಒಳಗೆ ಇದನ್ನ BE1 ಅಂತ ಬರೀತೀನಿ. ವೆನ್ ಐ ಕೀಪ್ ದಟ್ ಮಟೀರಿಯಲ್ ಇನ್ ದಿಸ್ ಫೀಲ್ಡ್, ದ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಮೂಮೆಂಟ್ಸ್ ಡೆವಲಪ್ಡ್ ಇನ್ಸೈಡ್ ದಿಸ್ ಈಸ್ 10 ಯೂನಿಟ್ಸ್ ಅಂತ ನಾವು ಅನ್ಕೊಳ್ಳೋಣ. If I keep that same material in another field BE2, and let me say the magnetic moments developed in this is 20 units. 20 units. Material same ada, but field change ಮಾಡಿದೀವಿ. ಫಸ್ಟ್ ಫೀಲ್ಡ್ ಅದಕ್ಕೆ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಮೂಮೆಂಟ್ಸ್ ಎಷ್ಟು ಡೆವಲಪ್ ಆಯ್ತು? 10 units. In the second field, 20 units. So which is stronger field here? Second field is the stronger field. How do we get to know that? By magnetic intensity. Right? So magnetic intensity tells us about the field, how strongly it can magnetize the material. About that it will tell. Second thing, intensity of magnetization. Intensity of magnetization is magnetic moments developed per unit volume. Magnetic moments developed per unit volume. How much it has got magnetized. That is the term related to the field, and this is the term related to the material. This is the term related to the material. So ಈಗ ನೀವು ಇಲ್ಲಿ ಇಟ್ಕೊಂಡಾಗ ಇದ್ರೊಳಗೆ 10 ಮ್ಯಾಗ್ನೆಟಿಕ್ ಮೂಮೆಂಟ್ಸ್ ಡೆವಲಪ್ ಆದವು, ಇಲ್ಲಿ ಇಟ್ಕೊಂಡಾಗ 20 ಮ್ಯಾಗ್ನೆಟಿಕ್ ಮೂಮೆಂಟ್ಸ್ ಡೆವಲಪ್ ಆದವು. ಸೊ ಹೌ ಮೆನಿ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಮೂಮೆಂಟ್ಸ್ ಆರ್ ಡೆವಲಪ್ಡ್ ಪರ್ ಯೂನಿಟ್ ವಾಲ್ಯೂಮ್ ಇನ್ ದಟ್ ಮಟೀರಿಯಲ್? ದಟ್ ಈಸ್ ಕಾಲ್ಡ್ ಇಂಟೆನ್ಸಿಟಿ ಆಫ್ ಮ್ಯಾಗ್ನೆಟೈಸೇಷನ್, right? And its SI unit is ampere meter. This SI unit is also ampere meter. Next, magnetic induction. See, magnetic induction means when you keep that material inside the magnet and it will get magnetized, inside the material there will be a magnetic field developed. A material ಒಳಗಡೆ ಒಂದು magnetic field develop ಆಗಿರ್ತದೆ. That is called magnetic induction. And it is given by B is equal to mu naught into the bracket I plus H. In few books, this intensity of magnetization they will represent it by M also. ನಾವಿಲ್ಲಿ ಕ್ಯಾಪಿಟಲ್ ಎಂ ಅಂದ್ರೆ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಮೂಮೆಂಟ್ ತಗೊಂಡಿದೀವಿ. ಸೊ ಹಿಂಗಾಗಿ ನಾನು ಅದನ್ನ ಐ ಅಂತ ರಿಪ್ರೆಸೆಂಟ್ ಮಾಡ್ಕೊಂಡಿದ್ದೀನಿ. ಓಕೆ, SI unit of magnetic field is Tesla or Weber per meter square. We know this. Magnetic susceptibility. Magnetic susceptibility is the ratio of I by H, intensity of magnetization to the magnetic intensity, right? Since these both are having same unit, it is unitless, right? That is magnetic susceptibility. Magnetic permeability, it is B by H, B divided by H. Relation between relative permeability and susceptibility. Relative permeability is equal to 1 plus susceptibility. Relative permeability is equal to 1 plus susceptibility, right? So remember the formulas. Okay, now the last point, the last thing, but very important, you should be knowing these things very clearly. You have to remember these things at any cost, right? Okay, so we'll now differentiate the magnetic materials. There are 3 types of magnetic materials: diamagnetic substance, paramagnetic substance, ferromagnetic substance. So we'll go on differentiating these 3 magnetic materials. First I will tell you, strongest magnetic material is ferromagnetic. Universal magnetic property is diamagnetic. It is universal magnetic property. It will be, that property will be present for all things. And this is strongest magnetic material, ferromagnetic material, right? Okay, next. First, let us understand effect of magnet. What happens? A diamagnetic material is brought near the magnet. Paramagnetic material is brought near the magnet. Ferromagnetic is brought near the magnet. So whenever these 3 materials are brought near the magnet, what happens? This diamagnetic substance will feebly get repelled. Feebly means weakly it will get repelled, right? It will get repelled. Paramagnetic material will feebly get attracted. It will get attracted weakly. And ferromagnetic material will get attracted strongly. It will get attracted strongly. ಸೊ ಫೆರೋಮ್ಯಾಗ್ನೆಟಿಕ್ ಮೆಟೀರಿಯಲ್ ಸ್ಟ್ರಾಂಗ್ಲಿ ಅಟ್ರಾಕ್ಟ್ ಆಗ್ತದೆ, ಇದು ವೀಕ್ಲಿ ಅಟ್ರಾಕ್ಟ್ ಆಗ್ತದೆ, ಇದು ವೀಕ್ಲಿ ರಿಪೆಲ್ ಆಗ್ತದೆ ಡಯಾಮ್ಯಾಗ್ನೆಟಿಕ್ ಮೆಟೀರಿಯಲ್ ವೆನ್ ದೇ ಆರ್ ಬ್ರಾಟ್ ನಿಯರ್ ಟು ದ ಮ್ಯಾಗ್ನೆಟ್. ನೆಕ್ಸ್ಟ್, if they are placed in external magnetic field, if these three materials are placed in external magnetic field, diamagnetic material will acquire feeble magnetism, feeble magnetization. It will get magnetized very weakly in opposite direction of the applied field. ನೀವು ಏನ್ ಫೀಲ್ಡ್ ಅಪ್ಲೈ ಮಾಡಿದ್ರಿ ಅದರದ ಅಪೋಸಿಟ್ ಡೈರೆಕ್ಷನ್ ಒಳಗೆ ಅದು ಮ್ಯಾಗ್ನೆಟೈಸ್ ಆಗ್ತದ್ರಿ, ಅದು ಬಹಳ ವೀಕ್ಲಿ ಮ್ಯಾಗ್ನೆಟೈಸ್ ಆಗ್ತದೆ. ಪ್ಯಾರಾಮ್ಯಾಗ್ನೆಟಿಕ್ ಮಟೀರಿಯಲ್ ವಿಲ್ ಆಲ್ಸೋ ಗೆಟ್ ಮ್ಯಾಗ್ನೆಟೈಸ್ಡ್ ಫೀಬ್ಲಿ. ಫಿಬ್ಲಿ ಅಂತಂದ್ರೆ ಇದು ಕೂಡ ಬಹಳ ವೀಕ್ಲಿ ಮ್ಯಾಗ್ನೆಟೈಸ್ ಆಗ್ತದ್ರಿ, ಬಟ್ ಇಟ್ ವಿಲ್ ಗೆಟ್ ಮ್ಯಾಗ್ನೆಟೈಸ್ಡ್ ಇನ್ ಸೇಮ್ ಡೈರೆಕ್ಷನ್ ಆಫ್ ದ ಮ್ಯಾಗ್ನೆಟೈಸಿಂಗ್ ಫೀಲ್ಡ್. ನೀವೇನ್ ಅದನ್ನ ಮ್ಯಾಗ್ನೆಟೈಸ್ ಮಾಡ್ಲಿಕ್ಕೆ ಫೀಲ್ಡ್ ಅಪ್ಲೈ ಮಾಡಿರ್ತೀರಿ ಅದರ್ ಡೈರೆಕ್ಷನ್ ಒಳಗನ ಮ್ಯಾಗ್ನೆಟೈಸ್ ಆಗ್ತದ್ರಿ, ಬಟ್ ವೀಕ್ಲಿ ಇಟ್ ವಿಲ್ ಗೆಟ್ ಮ್ಯಾಗ್ನೆಟೈಸ್ಡ್. Ferromagnetic material, it will acquire strong magnetization in the direction of magnetizing field. It will acquire strong magnetization in the direction of magnetic field. Next, in a non-uniform magnetic field, in a non-uniform magnetic field, non-uniform magnetic field ಒಳಗೆ ನೀವು ಏನಾದರೂ ಇಟ್ಕೊಂಡ್ರೆ, ಈಗ ನಾವು ಇಟ್ಕೊಂಡಿದ್ದು ಯೂನಿಫಾರ್ಮ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್. non-uniform magnetic field ಒಳಗೆ ನೀವು ಏನಾದರೂ ಇಟ್ಕೊಂಡ್ರೆ, diamagnetic substance will move slowly from stronger part to the weaker part. It will move slowly from stronger part to the weaker part. Paramagnetic material will also move slowly, but from weaker part to stronger part. This is slowly from stronger to weaker. This is slowly from weaker to stronger. And ferromagnetic material will move quickly from weaker parts to stronger parts of the magnetic field. It will move quickly from weak to strong. Next, if you keep the magnet or a magnetic rod in uniform magnetic field, ಈಗ ಒಂದು ಡಯಾಮ್ಯಾಗ್ನೆಟಿಕ್ ರಾಡ್, ಪ್ಯಾರಾಮ್ಯಾಗ್ನೆಟಿಕ್ ರಾಡ್, ಫೆರೋಮ್ಯಾಗ್ನೆಟಿಕ್ ರಾಡ್ಸ್ ನೀವೇನಾದ್ರೂ ತಗೊಂಡು ಯೂನಿಫಾರ್ಮ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಒಳಗೆ ಇಟ್ಕೊಂಡ್ರೆ, ಇಟ್ ವಿಲ್ ಗೆಟ್ ಅಲೈನ್ಡ್ ಇಟ್ ಸೆಲ್ಫ್ ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಟು ದ ಡೈರೆಕ್ಷನ್ ಆಫ್ ದ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್. ಆ ರಾಡ್ ನೀವು ಫ್ರೀಲಿ ಸಸ್ಪೆಂಡ್ ಮಾಡ್ರಿ, ಯು ಟೈ ಅ ಥ್ರೆಡ್ ಟು ದಟ್ ಡಯಾಮ್ಯಾಗ್ನೆಟಿಕ್ ರಾಡ್ ಅದೇ, ಇದಕ್ಕೊಂದು ಥ್ರೆಡ್ ಕಟ್ಟಿವಿ, ಇದನ್ನ ಫ್ರೀಲಿ ಸಸ್ಪೆಂಡ್ ಮಾಡ್ರಿ, ಹ್ಯಾಂಗ್ ಇಟ್ ಫ್ರೀಲಿ. How it will stand? If the field is like this, it will stand like this. It will stand perpendicular to the direction of the field, right? Next, paramagnetic substance. When it is freely suspended, the rod aligns itself parallel to the field. It will align parallel to the field. This will align perpendicular to the field. And this will also align. Ferromagnetic material will also align itself parallel to the field. Idu kuda namagu parallel age niltadri. So those both rods will stand parallel, this rod will stand perpendicular. Next, very important concept, quantity you have to remember, susceptibility. Susceptibility of diamagnetic material is small and negative. Small and negative means susceptibility is less than 0. Susceptibility is less than 0 and greater than -1. It is small and negative. Susceptibility of paramagnetic material is small and positive. It is greater than 0 and less than epsilon. Right? So it is very small and positive. ಇದಕ್ಕೆ ನೆಗೆಟಿವ್ ಅದ, ಸ್ಮಾಲ್ ಅದ, ಅದಕ್ಕೆ ಸ್ಮಾಲ್ ಅದ ಬಟ್ ಪಾಸಿಟಿವ್ ಅದ. And ferromagnetic material susceptibility is very large. It is greater than 1000. It is greater than 1000. Right? It is greater than 1000. That's why we say it is the strongest magnetic material. Next, relative permeability, mu r. Relative permeability, mu r. It is slightly less than 1. Relative permeability is slightly less than 1 and greater than 0. Slightly less than 1 and greater than 0. Relative permeability of paramagnetic substance is slightly greater than 1. It is slightly greater than 1, less than 1 plus epsilon. Ferromagnetic substance relative permeability is greater than 1000. So either the all quantities are larger other. That's why we call it a stronger magnetic material. So relative permeability is also greater than 1000 for ferromagnetic material. Next, if you come for permeability value, permeability, here we will be comparing the permeability of these three materials with the permeability of absolute permeability, right? So permeability of diamagnetic substance will be less than absolute permeability. Permeability of paramagnetic substance is greater than absolute permeability. Permeability of ferromagnetic substance is very much greater than absolute permeability. Smaller than mu naught, greater than mu naught, very much greater than mu naught, right? Next, effect of temperature. Here in diamagnetic substance, susceptibility is independent of temperature. It will not depend on temperature. In paramagnetic substance, susceptibility is inversely proportional to temperature. is inversely proportional to temperature. Where? In paramagnetic substance. In ferromagnetic substance, susceptibility is also inversely proportional to temperature only, but here it will vary in a complex way. Here also it is inversely proportional, there also it is inversely proportional, but it varies in a very complex way. Next, whenever you keep these magnetic materials in a magnetic field to magnetize ಮಾಡ್ಲಿಕ್ಕೆ ಅದನ್ನ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಒಳಗೆ ಇಡ್ತೀರಿ, ಆಮೇಲೆ ಅದನ್ನ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ದಾಗಿಂದ ತೆಗಿತೀರಿ. Correct? So what happens when you remove it from the magnetic field? After removing the diamagnetic substance from the magnetic field, magnetism lasts as long as the magnetizing field is applied. If you remove it from the magnetic field, its magnetism disappears. Other magnetism vanish agbiduತ್ತದೆ. Right? So it will be having magnetic properties, magnetic moments until it is kept in the magnetizing field. Once you remove it from the magnetizing field, it will again become zero. ಅಂದ್ರೆ ಮತ್ತೆ ಅದು ನಮಗೆ magnetism ಅನ್ನು ಕಳ್ಕೊಂಡು ಬಿಡ್ತದೆ. Paramagnetic substance, magnetism lasts as long as magnetizing field is applied. ಎಲ್ಲಿವರೆಗೂ magnetic field applied ಇದೆ ಅಲ್ಲಿವರೆಗೂ ಇವಕ್ಕೆ magnetic properties ಇರ್ತಾವ್ರಿ ಎರಡು. Magnetizing field ದಾಗಿಂದ ತೆಗೆದ್ರಿ ಅದರದ್ದು magnetism ಹೋಗ್ಬಿಡ್ತದ್ರಿ. That is dia and paramagnetic substance. Ferromagnetic, magnetism lasts even after magnetizing field is removed. Magnetizing field ದಾಗಿಂದ ತೆಗೆದ ಮೇಲೂ ಕೂಡ ferromagnetic material ಕ್ಕೆ ಇನ್ನೂ magnetic properties ಇರ್ತಾವ. Right? It will retain the magnetism. Variation of M with H. Variation of M with H. M ಅಂತಂದ್ರೆ I ರೇ ನಮ್ಮ ಪ್ರಕಾರ. M means it is I, intensity of magnetization. H is magnetic intensity. So M changes linearly with H, other directly proportional. M changes linearly with H and attains saturation at low temperature and is very strong in very strong fields. Illu linearly vary ಆಗ್ತದ್ರಿ, but it attains saturation. ಅಂದ್ರೆ ಕಾನ್ಸ್ಟೆಂಟ್ ಆಗಿಬಿಡ್ತದ್ರಿ. ಇಲ್ಲೇ M changes non-linearly with H and ultimately attains saturation. In these both cases, it will change linearly. Here it will change non-linearly. Okay, hysteresis effect. Magnetic vector. ಇಲ್ಲಿ ನೋಡ್ರಿ, ಇದ್ರೊಳಗ diamagnetic will not show hysteresis effect. Paramagnetic will not show hysteresis effect. Only ferromagnetic material will show hysteresis effect. So hysteresis effect ನಮಗೆ ಸಿಗೋದು ಬರೀ ferromagnetic material ಒಳಗೆ ಮಾತ್ರ. And remember one more thing, dia and paramagnetic substances are available in solid, liquid and gaseous form. But ferromagnetic is available only in solid form. It is available only in solid form, right? And you can also write some examples for these materials that will give you the clear difference between dia, para and ferromagnetic substances. So that is all about the magnetic materials and magnetism and matter. Dear students, if you like the content of this channel, please don't forget to subscribe the channel and share the video, share the channel with your friends, right? Thank you so much for watching and supporting the channel. Please keep watching and supporting the channel, and please put a comment if you need anything else. I will try to make the video on those things also, right? Thank you so much. Keep watching.